This lecture covers software quality metrics. Some of the conventional quality metrics are requirements, design, implementation, and system metrics. Requirements metrics include the unambiguity metric, which is a measure of the uniqueness of each requirement as measured by a percentage of the requirements that are interpreted as unique by reviewers. The completeness metric measures whether or not all states of a system are included in the requirements specification. Requirements correctness method measures the number of validated requirements. The requirements consistency metric measures the consistency of the requirements. These design metrics can be defined using a structured chart as seen in Figure 19.3 in the textbook. Some design metrics are fan-in, which is the number of modules that calls a given module. Fan-out is the number of modules that are called by a given module. Cohesion is the measure of the relevance of the functions in a module to the core functionality of a module, and coupling measures the data dependencies among the modules. The number of lines of code metric is used to indicate the number of defects, the amount of documentation, and the encode comments and other code-related metrics. The cyclomatic complexity metric measures the number of independent paths through a program and the number of tests required. Some system metrics are power consumption, memory consumption, performance, and reliability. Reliability is the mean time between failures, MTBF, which is calculated by adding the mean time to failure, MTTF, and the mean time to repair, MTTR. System availability is the percentage of mean time to failure divided by mean time between failure. Conventional quality metrics can be used for object-oriented software. All except the cyclomatic complexity metric are applicable to OO software. The OO paradigm introduces features such as inheritance, encapsulation, polymorphism, and dynamic binding. Along with these features are OO measurements and metrics. The weighted methods per class, WMC, is for a class is the sum of the complexity metrics of the methods of the class. The depth of inheritance, DIT, for a class is the longest inheritance path from the root to the class. The number of children, NOC, is the number of immediate children of a class in an inheritance hierarchy. Coupling between object classes, CBO, is the number of classes a particular class depends on. Response for class, RFC, is the number of methods of a class plus the number of methods called by a method of the class. Lack of cohesion in methods, LCOM, is the number of pairs of methods of the class that do not share an attribute of the class. Advantages of quality metrics are that indicators can be defined and used. Ranges of indicators can be specified that enable teams to spot problem areas quickly. Metrics and indicators are useful for identifying critical areas where more resources need to be directed. Metrics and indicators are useful for quantitative comparisons of projects and systems. Metrics are useful for quantitative assessments to determine if a change actually improved processes or systems.